In this video, we're going to go over the process of how we use a colligative property measurement to calculate the molecular weight of an unknown substance, and then we're going to go through a step-by-step example. Colligative property measurements are a really convenient way to get the molecular weight of an unknown compound. We commonly find undiscovered molecules, and learning the molecular weight is a first step in figuring out their structure. The way we would do this with osmotic pressure is by putting two liquids in the osmotic pressure device. The first one is the pure solvent that you're going to use in the measurement. That goes in on one side. On the other side, you're going to place a sample solution. This is your unknown solute dissolved in the solvent. Separating the two is a semi-permeable membrane. This will allow solvent molecules to move back and forth, but not the solute molecules. We want to first calculate the concentration of this sample solution in grams per liter from information that will be given to you in the problem. This tells you how many grams of the unknown solute are in 1 liter of this solution. So sometime later, the osmosis is complete. Pure solvent has migrated across the semi-permeable membrane, diluting the sample solution until it's dilute enough that essentially the universe is happy. It's reached equilibrium. If we look at the gap between the previous pure solvent level and the solvent level after the osmosis, we derive the osmotic pressure from this gap using some sophisticated calculations. We want to use this measured pi value to calculate the concentration of the sample solution in molarity. This tells us the moles of solute in 1 liter of the solution. The equation that governs osmotic pressure is pi equals IMRT. I is our Van 't Hoff factor, M is our molarity, R is the gas constant, and T is temperature. We want to solve for molarity, so we would use M equals pi over IRT. Finally, we're going to just assume that we have 1 liter of this sample solution. The grams per liter value tells you how many grams of unknown we have, while the molarity tells us how many moles we have. Molar mass is simply a ratio, the grams of the substance per 1 mole of the substance. Since we now know the grams and moles present of the unknown, we just divide the grams by the moles, and that gives us our molar mass. Let's put this into action with an example. Here's our example. While cleaning a lab, you find a powder that could be either glucose, 180.2 grams per mole, or sucrose, 342.3 grams per mole. Chemical tests won't tell them apart, but you have an osmotic pressure apparatus. You make a sample solution by dissolving 65.0 milligrams of the powder in 3.5 milliliters of water at 298 Kelvin. You obtain an osmotic pressure measurement of 2.519 atmospheres. What is the powder? Step 1 is to calculate our solution concentration in grams per liter. 65 milligrams of solute divided by 3.5 milliliters of solvent is the same thing as saying 65.0 grams of solute per 3.50 liters of solvent. You can go through the unit factor analysis conversions to confirm to yourself that this is true. If we crunch our numbers, we get that our solution concentration is 18.6 grams per liter. This is the value we will need near the end of the problem. Step 2, we need to calculate the solution concentration in molarity. This is where we'll start from that osmotic pressure measurement. We said that M equals pi over IRT, so we'll plug in our 2.519 atmospheres over 1 for the Van 't Hoff factor, because this is a molecular compound, times 0.08206 liter atmospheres per mole Kelvin, times 298 Kelvin. I put the units in here so that you can see that the atmospheres will cancel, as will the Kelvin, leaving us with liters and moles. When this leaves the denominator and goes into the numerator, the moles and the liters will flip places, putting us in the correct units for our final answer of 0.103 moles per liter. So now we have everything we need. Step 3, we're going to assume 1 liter of the solution. Based on our concentrations that we calculated, 1 liter contains 18.6 grams of unknown and 0.103 moles of unknown. Molar mass is grams over moles. We put our grams over our moles, and we get a final molar mass of 181 grams per mole. If we compare this to the two possible molar masses, our unknown powder is clearly glucose because our measured value is very close to the predicted value. I hope this cleared up how to attack these kinds of problems. If not, I'm always happy to see you in office hours, and I will see you next class.